Hey Team Bio, welcome to your screencast on the human heart. So we've been talking about cellular respiration in great detail. We've gone down to the nitty-gritty of small redox reactions that are happening, stripping high-energy electrons away from the molecule that once was glucose, or at some point in its history it was glucose. But today we're going to zoom out a little bit and we're going to talk about the heart and the connection of the heart to cellular respiration. So you all know that in every cell in your body, you are performing cellular respiration. The unbalanced chemical equation is C6H12O6, or glucose, that you all know and love, and oxygen. Remember, oxygen is the acceptor of the low energy electrons at the end of electron transport phosphorylation, and this is producing CO2 and H2O. So this is happening in every single cell in your body, and in order for this reaction to occur and keep going, we need to get oxygen in to every single cell in your body, and we need to get CO2 out of every single cell in your body. And what is the big pump that is supplying oxygen and helping remove CO2? Well, it's the human heart. So we're going to be talking about the structure of the heart today and how it circulates blood around the body, which is delivering O2 to all of your tissue and removing CO2. So I'm going to use two different colors throughout the course of this screencast, and anytime I use a blue line, I'm going to be talking about CO2 rich, which means O2 poor blood. Oops. Poor. And anytime I use a red line, I'm going to be talking about O2 rich, CO2 poor blood. Okay. So here's the heart. The heart is connected in a couple big loops to your lungs and then the rest of your body. So we could start anywhere and trace our way back to our starting point, but we're going to start with kind of, I think, a somewhat logical position of the heart. We're going to be talking about blood that is CO2 rich and O2 poor being delivered back to the heart right after it's visited the body. Okay, so here we have a big vein, and here we have a big vein. They are both depositing here and here into the heart. They are called the inferior vena cava and superior vena cava. This one is called superior because it's much better. Just kidding. This is delivering blood that has been up in your head and in your arms to your heart, and this is depositing blood that has been in your body cavity and in your legs to your heart. So this blood is CO2 rich because it's coming from the body, and O2 poor because all the oxygen has been dropped off. So the blood is dumped into a little chamber in the heart called the right atrium. Now, you might be wondering, this is the upper left-hand corner of the heart in our diagram. Why is it called the right atrium? Well, if you imagine yourself having this heart, this is actually you looking at the heart of somebody else. But if this was your heart, imagine picking up the paper and turning it around so the heart is facing away from your body, like the picture side of the paper is facing away from your body, and then holding it up over your chest, you would see that this is actually on the right side of your body. So when we talk about the right and left side of the heart, we're talking about in reference to the person that it's in, not the direction that we're looking at it in. Okay, so this is called the right atrium, and all the blood is dumped into the right atrium. An atrium is, like the atrium in Hanover High School, a waiting place, a hanging out place. And so the blood starts to pool in the atrium, and it's going to slowly trickle through a valve here. This is called the tricuspid valve. It's called tricuspid because it has kind of 3 little cups that come together when it closes. So the blood is going to move from the atrium, and it's going to fill up what we call the ventricle. This is the right ventricle. This is a C, C-L-E. Okay, so the right atrium fills up the right ventricle, and the right ventricle is going to, well, it's all going to like slowly fill up. Ooh, that's not what I wanted. I wanted my highlighter here. So blood's going to pool in the right ventricle, and ultimately what's going to happen is that the right atrium is going to squeeze, and then the tricuspid valve is going to close. When that happens, the right ventricle is then going to squeeze, and it's going to pump blood out of the heart through another valve that you can't see here, but it's called the pulmonary valve. So it's in there. And this artery is called the pulmonary artery. So the pulmonary artery actually splits off pretty quickly, and the blood is going to divide. Some of it is going to go this way, and some of it is going to go this way. And this is because both of these arteries are leading to the lungs. You have 2 lobes of your lungs, and so the blood is going to go into both your left and your right lung. Okay, in the lungs, it is going to drop off CO2, which you are going to exhale, and it's going to pick up oxygen that you have inhaled. So when the blood comes back to the heart through these veins here, which are called the pulmonary veins, so it's coming in here, and here, and here. These are the pulmonary veins. The now oxygen-rich blood, CO2 poor, is going to pool in the left atrium. It's going to move through the mitral valve, into the left ventricle. And the left ventricle, when the heart contracts, is going to squeeze blood out Again, there's another valve in here that you can't see, the aortic valve. Sorry, I put that in a place where you can't really see it. But the aortic valve is back in here. And the blood is going to be pumped through a giant artery called the aorta. Now, the aorta has a big arch in it. This is called the aortic arch right here, and blood is going to some of the blood is going to leave the aorta and go up to your noggin. It's going to go up to your head here, and then some of it is going to descend down the arch, and it is coming out here, and it's going to go feed your the rest of your body, like your body cavity and your legs. So this is all leading to the body. And then the blood is going to be collected from the body and deposited back into the inferior and superior vena cava, and then we're back to the heart again. While it is out in the body, oxygen is going to be dropped off and CO2 is going to be picked up. So by the time we come back to the right atrium, this is CO2 rich, oxygen poor blood once again. Okay, kind of cool facts about the heart. When you put your head on someone's chest and you hear the lub-dub, lub-dub, lub-dub sound, what you're actually hearing is the tricuspid valve and the mitral valve closing, and then blood hitting the back of them. And when you hear so the blood is squeezed from the right atrium and the left atrium simultaneously into the right and left ventricle. So it squeezes here, and then the heart squeezes here, and that squeeze forces blood back up and out the pulmonary artery and the aorta. And the dub sound of the lub-dub, lub-dub, lub-dub is the aortic and pulmonary valves closing. If you've ever heard of someone that has a heart murmur, what's happening is that one of their valves is not closing all the way, and they're getting some backwash into either the right atrium or left atrium, or a little bit more seriously, the right ventricle or left ventricle. And that is creating a murmur of the backflow of blood in the wrong direction. So depending on what valve it's happening in, it can be either more or less serious and might require surgery. Also kind of cool, there is a node kind of in the upper right-hand corner of the heart, which is called the SA node, and it generates its own electrical signal. So if you remove a heart from a body, it will continue to beat because the generation of the electrical signal is happening internally. As people age, sometimes part of their heart tissue can die, and the signal, the electrical impulse that travels down the heart and then back up doesn't occur as smoothly. So if someone, has a pacemaker, basically there's a little device in their heart near their SA node that's monitoring the electrical rhythm of their heart. And if it gets off, then the heart gets a little shock, zoop, and it resets that SA node and starts making the pumping pace again, or correcting the pace of the heart. So you can check the heart and get it to start again. Also, if you've ever seen an AED, a defibrillator, that is what's happening. You're shocking the heart and regenerating that electrical, or resetting that electrical rhythm. Okay, that's all.